So a little while ago, I made a video discussing this switch panel that I'm designing for my K25. I wanted the theme to be OEM Plus, and I think we're on the way to achieving that, and the initial prototype works exactly how I wanted it to. So now it's time to start thinking about refinement and also some other design improvements that need to be made. I was going to do this in a more difficult way, but after discussing it with Revopoint, they sent me out this 3D scanner to help with the project. So, let's get to it.
I see them copy the same old sound, painted our lives. But could you tell me what it is that I'm missing? Oh, keep that mind tucked in your prison. These prisms swell.
Yeah, or is it better if we overflow it? And birth poets, young kings set to overthrow it. Spread wings like what RD was just a scribble on some dotted paper. You hear things, now we major, huh? Long removed from the youth that I remained once. Now my crew maneuver your cities all on the same bus. Different kinds of louder, some sticky, all in the same blunt. Stayed hot through this.
I've already done a lot of the hard work with modelling these heater controls, and even if I hadn't, I would still like to scan this face in as bare a form as possible. So I'll remove the heater controls and cigarette lighter. The steel bracket is plastic welded to the face, and I don't want to damage the part. Regardless, for my design purposes, it's fine to remain on there. The main design features I'm concerned with are this curve of the faceplate, the mounting tabs either side and the top, including their relative angle, and the 3 mounting points for the heater controls. The scanner comes with this turntable and tripod, which should work well, although I'm probably approaching the limit of what is an ideal size here, but we'll see how we go. Lighting is one of the most crucial things with scanning, and generally speaking, scanners don't like dark, reflective surfaces, as you can see. There are a few different ways to overcome this problem, however one of my preferred methods is to use a developer spray. It's actually been a number of years since I've done this, and I've most certainly overdone it, but it will still work fine. Now you can immediately see the difference the developer spray has had, and we're ready to start scanning. Another feature of this scanner is this flash or light on the front, and I've also tweaked the exposure to be a little bit higher than the default setting. After playing around on the turntable, my suspicions of the part being a bit too big appeared true, and I decided to give hand scanning a go, which worked out well. Patience and practice is the key here. There's a lot of nuance with scanning, but generally speaking, I'm trying to capture unique features as opposed to the bare, flat areas, so that the scanner can keep some reference points. These reflective dots on the table also help with that, as I can use them as a flat reference plane when cleaning up the scan. I'll also use a few separate scans that I'll merge together, and when doing that it's also important that we have overlapping features in each scan so that we can properly align them. Sometimes you may find that you've lost tracking or some parts of the scans haven't come out as well as others, in which case you can just highlight and delete those sections and then rescan the area with enough overlap to align the two of them. The auto alignment with the scanner seems to work quite well. There was a couple of instances where it didn't quite do what I wanted it to do, but I probably should have just done a better job getting the scan in the first place. Now that's looking pretty good, so let's jump over to the computer and import what we've got. RevoScan 5 is the free software available on the website, and I've never used this before, so I'm just going to follow the bouncing ball, working my way through some of the scan cleanup options. First off, I'm going to use this isolation tool. I'd like to do away with these reference dots from the template, but we can see our first issue. 2 of the mounting tabs that I scanned are separate from the body, and it detects them as a stray piece. So I'm going to tweak the sensitivity of the tool until it picks up the scanning dots as outliers, but not the tabs. I'm not going to overdo it here. The scan is actually looking pretty good for my needs, so I'm going to mesh it and get it ready for export. Depending on what software you plan to import this into, you may also consider simplifying the mesh once you've created it. This essentially reduces the complexity and the file size. There's a bit of a misconception regarding 3D scanning that I will also address here. People often think that you just scan an item and then that becomes your final model. That's not actually how this works. Not for engineering anyway. We're essentially creating a 3D mesh reference that we can measure from to create a new solid part, or sometimes faces or surfaces, but let's not overcomplicate it right now. You've seen from other work that I've done that you absolutely don't need a scanner in order to reproduce, I'd actually say, most things. Where it can really help to cut down on time and also provide info that would be very difficult to measure or infer otherwise is for things like organic and compound shapes. You've seen from the work I've already done on this project that it can be done without scanning. However, for something like this fascia with the curved face and few reference points that are hard to measure from a datum, 3D scanning can actually help to speed up the process by a lot. So what I'm doing now is taking the average size from the scan for both of the holes, then I'm drawing a center line between them that I'll reference to the top edge. The scan determines this average radius to be 3.5519mm, so let's see what I measure. 7.1mm on the part, which obviously makes a 3.55mm radius, doesn't get much closer than that. And now the distance between the holes measure 126.4, so if I subtract the diameter to find the centers, that leaves 119.3, And that's a pretty good scan. Hopefully you can see what I mean though. Even though it's close, it's not quite right. And you can imagine how this error can compound over a large distance. This is true for basically every scanner. Now the measurement I'm most interested in is actually this radius cut for the face. 643.5-ish, and I'm pretty happy to round that up to 644 and call it a day. Now I've deliberately left some scan noise / loss tracking areas in the scan here to further demonstrate what I'm talking about regarding using the scan as a reference, not the Bible. I've still got the physical part in my hands that I can measure, and I'm just going to use this model here to get my shapes close, then confirm with actual measurements. The other thing to remember is that I'm not starting from scratch. If I was, my approach would be a little different. I have a pre-existing design that I'm updating, and I already have a couple of validated points that I can use as a datum. Therefore, this part is somewhat redundant for my model, but I'll just show a little of the process. Quite honestly, I've been dreading this a little bit because I actually started this model many years ago in lockdown as a bit of an exercise, and it's quite messy in terms of hierarchy. So going back and making changes is not the best way to fix it, starting again is. But that's alright, I've already confirmed a lot of things, so I can copy a lot from my other model and my new scan, so this should go pretty quickly. And I'll be able to keep the heater control portion of the model as I've already made that modular, so we're well on the way. But this is how I'm going to restart. The side profile is a combination of the scan and measurements, as I've discussed, and first off is going to be the top mounting points. They're symmetrical about the center line of the face, so that will flow nicely. I'm going to thicken it up in a couple of places as I'm not using the metal support bracket like the OEM one. Side profile is next, which I'll cut away from one side and then mirror. And then the two side mounts are predetermined with the existing model, so I've just got to copy that info across. And now it's probably about time to make a test piece. As you've heard me say before, I'm interested in a fast turnaround here, so I'll hollow and trim out unnecessary parts of the model so that I can reduce the print time. Oh, and I've got some new printers. More on that later. But I also made something that's been on my brain for quite some time as well, which is this shelf. I'm not sure that I've ever actually shown on here how this desk came to be in my possession. It was actually a classic marketplace find that was just too good to pass up. The guy told me that they'd brought the desk up through an opening that had since been framed in and was convinced that we'd never get it out of that door. Obviously he'd never met Troy and I before, and I reckon he still tells his story to this day. Right. He couldn't believe that we got it out of there. So at this point you can see we've got it halfway out.
I did this all by myself.
Right. How you feeling, mate? Good?
I'm excited.
We work out how to get it down, and we came up with this idea with the strap.
Today's a nice day to be squashed, isn't it?
Look, it couldn't be slipperier. But yeah, once it was on there, we were good to go, and it was coming down. So
How you doing there, mate? Good?
for obvious reasons, we couldn't film it on the way down because it was all hands on deck. So anyway, here it is, and it's quite deep. Not only that, there's a gap of dead space at the back here, and as most people with small spaces are familiar, maximum utilization is key. I've been in a state of decision paralysis about this because I don't like damaging things, and I didn't want to drill into the top in the wrong spot or make a piece and realise it'd be better another way. But I just set myself an allowance of one afternoon, and it had to be functional at the end of that day. Save from gluing the trims on, which I did overnight, I managed to achieve that. I'll swap these screws to countersunk ones, now I'm happy with it, and I was considering also putting a skin over the top, but for a V1, it does the job. You might remember from my previous video me talking about the small size of this build plate. Well, there's going to be some changes to the plan now, time for some big resin prints. Cable management also needs to be sorted out, but I'm not 100% set on the layout yet, and given my sometimes erratic nature, it's probably best I don't handle resin over the unsealed timber. Finally, something else I've been dying to do is wax these drawer runners. Unfortunately, I only had a sealing wax on hand, but better than nothing, and I'll come back to this. Okay, tangent over, let's check out our test print for our mounting hole orientation. This is looking pretty good, although this top mounting tab needs a more acute angle. Hard to show on the camera here, but basically we've got to do this. Beauty, I'm happy with that, so let's try a slightly larger print and ensure all the holes are in the right spot. The center's hollowed out, but I forgot to adjust my support settings because I'm very sleep deprived. We all make mistakes. This looks ugly, but it shouldn't really affect things. I double checked hole positions with the vernier to confirm, and we're still bang on to the model. I'm exaggerating the movement here in the video, but one last tweak to that angle and I think we'll be perfect. So I added some more of the features from the other design to see how it's all looking, and put on a longer print. Seeing as this was going to take quite a few hours, I turned my attention to something I'm going to need to be functional pretty soon. I've now got a VFD sorted for the Bridgeport, so that means I can actually power it up and put it to use. But that also means it's time for a clean. I've got to mount the VFD, and this power feed needs some oil and a new seal. I really had to set myself some limits for this because all I want to do is tear it down and clean every little piece of it, but I've got to keep reminding myself that I'm not half-assing it, I'm prioritizing. And right now the priority is get it working. This gasket will be simple enough to model up in CAD and I'll print one from TPU, but before I do that I'm going to push on here to make sure there's no surprises waiting for me. Pretty cool dogtooth gear engagement here, while this lever lets you switch between hand cranking and power feed as well as direction for the power feed. Considering the price difference and finicky nature of TPU, I will often print a test piece from a cheaper material like PETG or PLA first before committing to the design. That design fit well, so I prepped the TPU print while I kept cleaning. It looks a little glittery in there, but I'd confidently wager that this cover has never been removed, so if that's all that's in there after 50 plus years of life, I think that's not too bad. And I'm definitely not getting carried away with cleaning here, just giving it a little wipe over, that's all. Just cleaning up the areas while I've got access to them, that's all. Well, I mean, I might as well take this off and just give it a little wipe. I'm right here. And this will only take a sec. Look, I could have pulled the whole switch panel apart and I didn't, so I think that deserves some recognition. This would probably be fine with just a new seal, but we're here now, so I'm going to give it a light sand to smooth it out. You can see this low spot over here. I'm not sure I want to go too crazy trying to get it completely out. I'll see how far this sheet of sandpaper will get me and I'll probably leave it there. Good enough, I think. Here's our new TPU gasket. I put this little date tab on there for the next person to find, not that I have any plans of ever selling the Bridgeport, and for those of you unfamiliar with TPU, it's quite flexible. That's Dad's fault. Forgot to show you this. A little bit of metal in the bottom of the fluid as well, but like I said, for 50 years, I don't think that's too bad. I wasn't really sure about greasing this, to be honest, but I did. So if you know better, you can let me know in the comments. I'm ready to call this one a success. I'm also not at all going to get distracted by other things to clean. It's time to mount up my new vise, just after I put this on and give it a wipe. Viva was kind enough to send this one out to me to test out. It obviously does come with this rotary attachment, but I prefer to mount it solid to the table for maximum rigidity. But everything seems great. Regardless of where I got it, I would always pull something like this apart anyway to have a look, and it looks to be very high quality. I run a dial gauge over the surfaces and everything's actually pretty damn good. Pretty minor, but the edges of the jaws are a little sharp and could probably do with breaking, but it's almost not worth mentioning. Seems like these channels are going to be well suited to coolant flow, and the jaws at full extension measure, say, just under 153mm. And if we were to swap them to the outside, you're going to have to forgive the blasphemy that is using a tape measure on machinist equipment, but we've got about 325mm of utility. It's a bit hard to see, but there's another drain hole under here, and easy access for oiling on the front. The VFD I mentioned is also from Viva. They didn't gift it to me, I bought it with my own dollary dues. It's working well, but I needed somewhere to mount it. The cables would just run down this split loom and all tied off neatly. We know how much I don't like permanently modifying things, so I decided to utilise these two existing bolts on the switch panel. I was also missing some collets. Viva didn't send these to me either. I also bought these with my own dollary dues, and they look to be quite good. I was very much looking forward to trying these out, however I've encountered another issue that needs resolving. This is the spindle brake, and ideally you would engage this to secure your spindle while you tighten and secure the tool, but it's not working. I'm hoping it's just due to years of inactivity and needs a clean, but that means pulling the whole top off the head, and it's just going to have to be a job for another day. And besides, it's time to check out our fascia. Remarkably, I again forgot to change the support settings and left on a PETG interference layer. This helps when printing parts that have a high overhang angle, like the flange I made for the J-pipe jigs, But for parts like this where I really need it to stick to the support, we can see it separated and cause some warping. Anyway, for the tester, it's fine. Moment of truth, and it fits perfectly. Except for how proud it sits over here, and I've got to admit I was a little concerned I'd mess something up, but upon checking the OEM piece, it turns out the alignment is just not great. So I'm going to probably have to space out the cluster as well, which is fine. And it's actually reminded me that I wouldn't mind making a model of the cluster so I can make an OEM Plus style one. I don't want to modify this genuine Sprinter dash, and the standard K21s don't have a tacho. I should probably also reprint this gauge holder too, but before I do that, I've been working on this little project in the background for a while now, and it may or may not have something to do with attempting to design my own cross-flow dual overhead cam head for the K engine. But that's a bit of a slow burn. I'm collecting some parts, so if you've got any 4AGE or 2ZZ bits you want to get rid of, let me know. But in the meantime, the Turbo K70 is a secondary priority to this switch panel, and now that I've finally got that profile sorted, I can start moving forward again. I said previously that I was going to print this fascia from ASA on the FDM machine, but now that Elegoo has sent me this massive Jupiter resin printer, I'm going to print it on there. There's lots and lots more to come. I'm really excited to show you all the things that I've got planned. If you like this video, let me know in the comments. If you didn't like this video, you can let me know that in the comments too. Thanks for watching. I really appreciate it.
Kids are barely 6, 17, man, they virgins observant. The pressure put in our seeds to get straight A's. I know I was rushing home just to get straight blaze. You know the age, naivety, frustration, and rage. Suicide rates constantly raised, and I'm amazed. Graduating, maybe you can work the rest of your life. Education for some dreams and aspirations aside, y'all get the picture. These kids are falling victim to a system, raising money hungry in a food scarce prison. And when that prison is the building blocks for a whole generation, it takes someone great to instigate some separation, know what I'm saying? So stand alone, fucking stand tall, dog. You can always get up higher than you fall, dog.